Hello students, today we are going to start mathematics paper first, matrix algebra. Its code is MTC111. First chapter is matrix algebra. First topic is matrices. First we will see definition of matrix. A matrix is a rectangular array of m by n real or complex numbers arranged in m horizontal rows and n vertical columns, which is enclosed between square brackets. A matrix is a rectangular array of m by n real or complex numbers arranged in m horizontal rows and n vertical columns, which is enclosed between square brackets. For example, 1 5 3 0 2 1. Second example is 1 2 3 4 5. Third example is root of 3 2 0 2 3 1 1 2 3. These are the examples of matrices. These are the horizontal row and this is vertical column. The size of matrix is described by the number of rows and number of columns that occur in the matrix. The size of the matrix is described by number of rows and number of columns that occur in the matrix. The first matrix in above example has three rows. 1 2 3 has 3 rows and 2 horizontal columns. 1 2 and 2 columns so that size said to be, so that its size said to be 3 by 2, and it is written as 3 by 2. Students, always remember that first number denotes the number of rows and second number indicates the number of columns. What is the size of second matrix? In this matrix, number of rows is 1 and number of columns 1, 2, 3, 4, 5. Number of columns are 5. Therefore, size of this matrix is 1 by 5. Now, what is the size of this matrix? In this matrix, number of rows are 1, 2, 3 and number of columns are 1, 2, 3. Therefore, size of this matrix is 3 by 3. Students, we have to remember that generally we use capital letters A, B, C and so on. We use denote the general matrix. That is, we use A, B, C for denote the matrix, and lowercase letters such as A11, A12 to denote the numerical quantities to write general matrix. A general m by n matrix, A is always written as A11, means entry in first row, first column. A12, entry in first row, second column, and so on up to Aij, means entry in ith row and jth column, and so on up to A1n, since number of columns are n. Second row is A21, A22 and so on up to A2j and so on up to A2n and so on up to ith row AI1 and second entry is AI2 and so on up to AIJ and so on up to AIN. This is and so on up to number of rows are n. So it is up to n. And this is first column. Second entry is AM2 and so on up to AMJ and so on up to AMN. This is a general matrix. Suppose call this equation number 1. The ith row of A is, what is ith row of A? This is a ith row of matrix A. AI1, AI2 and so on up to AIJ and so on up to AIN. Here 1 is less than or equal to I is less than or equal to n, and jth column of A is, what is jth column? This is a jth column for matrix A. AIJ up to AMJ, where 1 is less than or equal to j is less than or equal to n. Here AIJ denotes the entry Aij denotes the entry which occurs at the cross section of ith row and jth column. Ith row and jth column. Sometimes the matrix A of size m by n can be written as A is equal to matrix Aij m by n, which indicates the same matrix in equation 1, which indicate the same matrix in equation 1. Here, if m is equal to n, m means number of rows is equal to number of columns. When number of rows is equal to number of columns, we say that matrix A is square matrix. We say that A is a square matrix. When A is square matrix, if m is equal to A of order n. See here, this A11, A22 and so on up to ANN. Here we considering square matrix. So ANN are the main diagonals of A. Which are the diagonal? A11, A22, A33 and so on up to ANN are diagonal. The number Aij is called I comma jth entry, that is ijth entry of A. Students, always remember that Aij is nothing but ijth entry of A, capital A. A 1 by n or n by 1 matrix is also called an n vector. And will be denoted by letters with an arrow on the top. Here A1 by n means it is a matrix with size 1 by n, that is number of row is 1 and number of columns are n, or number of rows are n and number of columns is 1. For example, u bar is equals to matrix 0 1 2 minus 3 is a 4 vector. Since size of this matrix is 1 by 4, number of row is 1 and number of columns are 4, therefore it is a 4 vector. Why u bar? Because this 1 by n or n by 1 matrix is called an n vector and it is denoted by letters with an arrow. So it is u bar. Next is y bar is equals to minus 1 0 2. It is a 3 vector. Why it is a 3 vector? Because size of this matrix is 3 by 1, therefore it is a 3 vector. Let us see different types of matrices. First matrix is diagonal matrix. See, what is the definition of diagonal matrix? A square matrix A is equal to matrix Aij is said to be diagonal matrix if Aij is equals to 0 for all I is not equals to j. That means diagonal matrix is a matrix in which only diagonal entries are non-zero. For example 2 0 0 matrix 2 0 0 5. Second example is matrix minus 1 0 0 2 0 0 0 minus 3. See, in this example only diagonal entries are non-zero and other entries are 0, therefore it is a diagonal matrix. Let us take next definition of scalar matrix. A diagonal matrix A is equals to matrix Aij. A diagonal matrix A is equals to Aij is called scalar matrix if all the terms on main diagonal are equal. Scalar matrix is nothing but diagonal matrix in which all the terms on the main diagonal are equal. For example, matrix A is equals to 2 0 0 2. In this matrix diagonal entries are in this diagonal matrix diagonal entries are same, therefore it is a scalar matrix. Next example is 3 0 0 0 3 0 0 0 3. It is also scalar matrix since it is a diagonal matrix and all diagonal entries are same. Let us take next definition. Two m by n matrices matrix A is equals to matrix Aij and B is equals to matrix Bij are said to be equal are said to be equal if Aij is equals to Bij, 1 is less than or equal to I is less than or equal to n, since number of rows are n, and 1 is less than or equal to j is less than or equal to n, since number of columns are n. Two matrices A and B are said to be equal if Aij is equal to Bij, that is if the corresponding entries are equal. That is, if corresponding entries are equal. That is, A11 is equals to B11, A12 is equals to B12, and so on. For example, the matrices A is equal to X matrix X2 4y and B is equal to matrix 6 B2 B3 minus 4 are equal only if X is equals to 6, since two matrices are equal if and only if the corresponding entries are equal. Therefore, A and B are equal if X is equals to 6, B2 is equals to 2, 4 is equals to B3, and Y is equals to minus 4. Thank you.